My dear students, today I'll take the topic on PN junction diode. Already you know the important material used to construct this PN junction diode is nothing but semiconductor. The semiconductor contains two kinds of charges which are responsible for the flow of current through the material. One is called electrons, second one is named as holes. These two are the charges which are responsible the flow of current through the semiconductor. Now diode come under this category of semiconductor. Here the semi is a term applicable two kinds of charges. Semi means two kinds of charges. What are those charges? One is named as electrons, other one is named as holes. Now the semiconductor is mainly responsible the flow of current either through electrons or holes. Based on this semiconductor property, many electronic components are designed or constructed. One of the basic component is the diode. One of the basic component and a preliminary component using semiconductor materials are nothing but diode. What are called semiconductor materials? Germanium and silicon are termed as the semiconductor materials. Now these diodes are constructed either by germanium or these diodes are constructed with silicon. Compared to germanium and silicon, the preferable material is silicon. That reason most of the diodes are used with the basic material is nothing but silicon. And the same silicon is extended in all kinds of integrated circuits. That is short form is named as ICs. That means the component what you learn is not only limited at this particular context. It is extended to up to the point of integrated circuits. There you take the main material to construct the integrated circuits are nothing but semiconductors. The suitable material for that construction or the designing of the electronic circuits is mainly silicon. Come under the operation of this particular diode, I'll describe briefly now. First thing is that this is called the schematic representation of PN junction diode. One side is named as P type, other side is named as N type. Those two are connected through ohmic contact. This is named as the ohmic contact. Ohmic contact. Other side is also named as ohmic contact. The significance of ohmic contact I tell you later. Ohmic contact. This is called electrode 1. Electrode 1. And it is named as electrode 2. Electrode 2. Electrode 1, electrode 2. The main significance of this is it is a P type and N type both are combined on a single semiconductor material. Now these two are interconnected with the metal contact. This is called the metal contact and it is also metal contact. Both are existing external with respect to the PN type material. These they are metal and N side connected through ohmic contact and metal and semiconductor connected through ohmic contact. The purpose of this ohmic contact is the same current flow possible on both sides of the terminals. The same current flows both sides of the terminals with the support of ohmic contact. And another point is it's a heavily doped materials. These are heavily doped materials are connected to the metal only through ohmic contact on both sides of the single semiconductor bar. What I am defining, what I am showing on this board. Come to the P type and N type. Already aware of the basic mechanism for the formation of P type and N type due to heavily doped, because the doping also different procedures are there. Using the doping process, the p-type is formed at one end and n-type is formed at the other end. With the support of these two p-type and n-type, there is a possibility of current flow through the diode. That is nothing but semiconductor material. Now comes to this is the basic construction of the schematic diagram of the PN junction diode. Ohmic contacts are joins the metals through this heavily doped semiconductor through this ohmic contact. Current equally distributed and heavily doped materials are connected to the metal through these ohmic contacts. Okay. Come in symbolic representation, because very frequently we are using this symbol regularly in all kinds of various semiconductor devices. One of the basic devices is diode. That is a basic symbol. Now here you observe now, it is a identification purpose only. I tell you, it is a triangular shaped symbol. At the edge is connected by one vertical lead, and here the long lead, and on the opposite side also one more long lead. This is nothing but what? Electrode 1. It is nothing but what? Electrode 2. Now the electrode 1 side is named as positive and other side is named as negative, because this positive describes the P side and negative describes the N side. Positive describes the P side and negative describes the N side. That is the alternative equivalent form. To discuss the electronic circuit operation and for the calculation of various parameters like current, voltage, etc., it is very frequently used alternative model of the diode. Symbolically, this is the form. Here the positive terminal, it is a negative terminal. Now the electrode 1 and it is electrode 2. Now come back to the basic point here, because entire operation discussed with the help of this diagram. Now here again I will back to the point briefly. It is a p-type and n-type, the same thing I redrawn here. P-type and n-type. You know the at room temperature there is a possibility of formation of one layer around the junction. One is P side and opposite side is N. Here dotted line indicates this is a region is formed due to recombination of the electrons and holes at room temperature, at which the charges are accommodated, at which the charges are accumulated, at which the charges are existing without external supply or without external voltage or without external potential. At room temperature, this kind of layer is formed itself after doping with respect to P and with respect to N. The layer which is formed around it, this is only existing at room temperature without external energy. Without external energy, this layer is formed at room temperature. What's the significance of this layer? Layer is nothing but region. What's the significance of this region? This region itself accommodate some kind of charges which are coming from P move towards N, and which are coming from N move towards P. Those charges are, some charges are appeared across the junction or around the junction. One is electrons named as E, and other side named as holes, like this. Electrons and holes. We observe now at room temperature, it is very easy to understand. The number of positive charges, number of negative charges are equal at room temperature. Once these are equal, that does not allow the movement of the holes from P side to N side. Similarly, electrons from N side to P side, because these are equal on both sides. That indicates what? The number of electrons is equals to number of holes. Whenever the number of electrons and number of holes are equal, that is a neutral state, or at the thermal equilibrium, or at the room temperature, at which the electrons and holes count should be equal. There is no movement of additional electrons or the holes to cross this depletion region. Its own is not possible. Now that is the case existing only at room temperature, based on the construction of this material or at the manufacturing time. The charges which are formed nearer to the junction on P end Similarly, the charges which are formed on the opposite side of the junction, they are the electrons. These are existing at room temperature. After formation, there is no further flow of charges from P to N and N to P. Now, with this reason, to break this condition, to reduce this particular count of the number of holes and number of electrons which are appeared around the junction, you want to break this, you want to reduce this, you want to change this condition, you require the external bias, the external potential, that is called external biasing. The name is here, I am using the term biasing. What is the meaning of biasing? Potential, voltage, energy you have to apply it against the P side as well as the N side. Whenever to apply the P side and N side, this external bias to be applied against P side and N side, this condition is disturbed. This condition is changed. Whatever it is, the electrode 1 on one side, electrode 2 on the other side. To break this particular situation, where the count of the charges around the junction should be equal, then no flow of current through this. This is also termed as open circuit condition. What is this named as? Open circuit condition. Under open circuit condition, no flow of current through the component or the semiconductor. Now it is a basic symbol already I told. To break this situation, either by increasing the number of charges one side compared to another, either P is more than N or N should be more than P. Whenever earlier case is what? P equals to N. At this situation, no flow of current through the semiconductor. Whether diode or transistor, whatever are there, semiconductor devices are there, there is no flow of current through that. Only at the time of P equals to N, it is existing only at room temperature. Now the count of the number of charges both are equal around the junction. At this time, current should be 0. But our objective to allow the flow of current through this, to regulate the flow of current through this. How to regulate? By controlling by external source. You want to control by external source, then possible to regulate it. That way is possible by changing the condition of P to N in the form of P greater than N or N greater than P. This is possible only after giving external voltage, that is named as biasing. What is that name? Biasing. With the help of the term biasing, there is a possibility to break this situation. At this time, the P not equals to N. In what way it should change? Either P should be more than N or N should be more than P. P should be more than N, N should be more than P. Now, after giving this, what happened? I'll discuss those points now. Now, the biasing are given to the component. This is the basic symbol of the potential. One is the positive lead, another one is the negative lead. Whenever to apply this potential against this component, then there is a possibility of current flow to the diode, and as well as the regulating is possible with the help of this external potential. Okay, now come to those points now. Now initially I select the P type and N type region. It's a P region and N region. Already I told you it is a ohmic contact, externally connected. It is also ohmic contact, is connected. Now here one element I considered, it is called the limiting resistor. Now here I apply the biasing with respect to the PN layer, or also termed as diode. Now it is very easily we can express the mechanism of connection is, one is named as, because biasings are again two types, I named as those. One is, short form is forward bias. One is named as forward bias, and second one is named as reverse bias. One is forward bias, second one is reverse bias. What's the meaning of the forward bias? We observe now, positive terminal of the supply is connected to P side and negative is connected to N side. It is a conventional and very easily to remember. Positive connected to P side, negative connected to N side is called the forward. The term indicates forward means the right direction or the existing conventional and easy direction where the flow of current possible through the PN layer or in terms of diode, the basic connection is positive connected to P side and negative connected to N side. To reverse this, what way to reverse now? You give the connection in opposite manner. That is, negative is connected to P side and a positive is connected to N side. That's called reverse. Earlier form should be changed. The earlier form should be changed in opposite way. That is called the reverse. That means what I observed, positive connected to positive, negative to negative is termed as a forward. Opposite we have to connect negative to positive and a positive to negative. We observed in the reverse bias. But the majority of the application we can finding and the complete operation to be observed in what biasing? Forward biasing. I will demonstrate those points in understandable way. Listen now. Positive to positive, negative to negative. Here what happened, whenever to connect this positive to positive and negative to negative, we also know the applied potential named as is V. Now earlier some points already executed. What are those? You forget this sometime. Now around this, what is formed now? Junction is formed like this. Around this is called the junction. One is around the junction is one side is P and other side is N. Without this, already I told you, some kind of charges are appeared. Some kind of charges are appeared on positive on one side and some kind of charges are appeared negative on opposite side. These are equal in count. Without this, it is at thermal equilibrium condition or at the room temperature. This is the status. This is the status. Now after this, giving this supply, giving this biasing, what happened in this particular region? This region I am separated like this. This is called the separated layer. It is called the junction. Like this, I try to show it now preliminarily, which is separated between them equal spacing. That means the P side to N side and like this P and N, the widths are same. The widths are same. The P and N widths are same under open circuited condition or unbiased condition. This is called unbiased. Now we are applying the biasing now. Once to apply the biasing, now the forward biasing once you are applied, then what happened? The change you observe now like this. Now whatever the junction is appeared here, the depletion layer is less width compared to the N side. That means the layer has to be shifted where the P is more biased compared to N. Then that around the depletion region area what you are observed equally distributed on both sides. The width is same on both sides. Whenever to give the external biasing of this kind, then positive side the amount of width is less compared to the negative side. Compared to the negative side. Yeah, another way also possible. What is that? Here the particular layer which one I am showing in this diagram. N side you give the more bias. Then P side is less bias. At this time the width is narrow on N side compared to the P side. That means there is a shifting of this depletion region width around the junction after giving the bias. That means the width should be narrow on P side and wider on N side by giving the more positive with respect to P side. Even in the reverse way, negative to be applied with respect to this. At this time, N side is more heavily doped compared to the P side. The narrower region is on N side and a wider region is the P side. That means N side is thin width and the P side is thick width. The shifting is done against the diode after giving external biasing. That means the depletion width is not fixed size which is appeared on P and N side of the semiconductor. It should be adjusted by giving external biasing, by giving external potential. Finally concluded now, P side is more supply had given, the width is narrow, N side is more penetrated towards N, becomes maximum. If the N side to applied, it penetrates towards P side is more. P side is more, N side is less. Compared to earlier case, P side is less, N side is more. Due to this adjustment, the flow of current should be regulated by the semiconductor by using external voltage. Now back to the point now. Now here you consider the same thing, the internal operation I will discuss now. This is the junction is formed now around it like this. Because of visibility sake, I am showing this much of it, but practically it is not that kind. Now the regulating of the current purpose or the safetiness of this device by external potential, we are using this limiting resistance. Otherwise the component has to be broken due to excess currents drawn by this coming from the external voltages. Now it is a positive or negative, it is the limiting resistors. Okay, now here what happened at the time of giving external biasing to the component, what kind of operation has to be executed. Now observe now, this is a P side and it is N side. You know the charges are which are present majority on P side are holes. Similarly, the electrons are coming from the N side, already aware of this. They are called the electrons or the field charges and the empty charges. These are. Now these are the charges are tried to enter like this. Similarly, holes are entered like this. Now the holes move towards the N side and electrons are moved towards the P side. And holes are moved towards N side. Coming from this point, what charges are started? Negative charges are started. Now those negative charges passing through the N side and again enter into the P side, and some more charges are coming out of the semiconductor P block that will reach the opposite side of the battery, that is on positive side. That means what is observed? Electrons are entered through N side, crossing the depletion region and passing through the P region, again return to the positive side. That means the positive charges are attracted by, or the negative charges are attracted by positive terminal. These are originated from negative terminal of the originated from the battery. All the electrons are moved towards the N side, crossing the junction and passing through the P region and return to the positive terminal and opposite terminal of the battery. Then the circuit should be closed. The entire circuit should be closed. Then only possible to regulate the flow of current through the diode or any semiconductor material. Clear my point? That means the electrons are coming from this and entered into the N region, passing towards the depletion region and crossing the P region and return to the same supply opposite terminal. What is an opposite terminal here? Positive. That means begins at negative. If you imagine begins at negative and passing through this, return to the positive.